In this thesis, we developed a robotic system for object retrieval in Clutter. The task here is for a robot to retrieve the target objects in Clutter. Here we have a fetch robot and a few objects on the table. Our robot can actively gather information of the environment using the head camera. Our robot can also physically interact with the objects by picking, placing, and pushing. Now I will showcase the skills of our robot. Our robot is able to retrieve the target objects even if it is partially occluded. The target object here is the apple. Here, the apple is incorrectly recognized as the orange because it is partially occluded. To gather more information, the robot first moves away the mustard container. Now the robot decides to look again. This time, the apple is correctly identified, and it can go ahead to pick it up. Our robot is able to find the target objects, even if it is fully occluded. Initially, the robot doesn't see any apples on the table, so it reasons that the apple could be behind one of the observed objects on the table. Hence, it first moves away the chip box to check what is behind, but the apple is not there. With this new information, the robot reasons that the apple could only be behind the mustard container. Hence, it moves away the mustard container. After taking another look, the robot finally discovers the apple, and it happily picks it up. Our robot is able to handle complex environment with multi-layer occlusion. In order to retrieve the apple, the robot first moves away the blue cup in the front. Without taking another look, the robot moves away the sugar box to fully review the apple. Now it's able to pick up the apple. Our robot is flexible enough to push an object if it cannot be picked up. In this case, the robot needs to move away the coffee can, but the coffee can is too large for the robot to pick up. Hence, it pushes the coffee can away. Now the robot is able to pick up the apple. Now we showcase all three manipulation skills in action. The robot first pushes the large coffee can to the back of the table to create some space in the front. The robot now is able to pick up the sugar box and place it in the space just created. After which, it is able to pick up the apple. Our robot is also able to move objects outside of the table when necessary. Here the robot observes that there is not enough space on the table to move objects around. Hence, the robot decides to move out the sugar box directly. Now it is able to pick up the apple. Finally, we illustrate the importance of multi-step look-ahead planning. Our robot is able to look ahead and reason that in order to retrieve the banana, it needs to move away the sugar box. And in order to move away the sugar box, the robot needs to first move the can to the back to create some space. Now the robot can move the sugar box to the space just created. And finally retrieve the banana. Meanwhile, the baseline system suffers miserably because of its greedy policy. Without multi-step look-ahead planning, it chooses actions suboptimally that maximizes the immediate reward rather than the long-term reward. No matter how it moves the sugar box, the banana cannot be fully reviewed. The baseline system is stuck in an infinite loop of moving the sugar box from left to right and right to left. This is the end of the video, and thank you so much for watching.